Hello everyone. Today we'll be starting a new chapter, that is chapter 3, and the name of the chapter is Understanding Quadrilaterals. Now, what is a quadrilateral? What are the types of quadrilateral? And the topics which are related to the quadrilaterals will be discussed in this chapter. So let us begin. Now first of all, let us know what is a quadrilateral. Since the chapter deals with quadrilateral, we should be aware of what is a quadrilateral. Now, according to the definition, a quadrilateral is a closed plane surface figure which has 4 straight sides or edges and 4 corners or vertices. For example, a square. A square is a type of a quadrilateral. There are also different other types of quadrilateral. We will come to that. So I hope it is very clear from the definition itself that what is a quadrilateral. It should be closed. It should be a plane surface figure. That is, it is a 2-dimensional figure, not a 3-dimensional. And it has 4 sides. The sides can also be called as edges. It has 4 corners or the vertices. So I hope this is clear to you what is a quadrilateral. Now moving on. Next, what is a plane surface? We have come across this thing called plane surface here in the quadrilateral. There is a word mentioned as plane surface. So what is a plane surface? So a plane surface can be defined as a flat 2-dimensional surface. As I already told, that a quadrilateral is a 2-dimensional surface since it is a plane surface. So whatever plane surface we know, those are all 2-dimensional. That means it has a length and it has a breadth. So these are the 2 dimensions. So a plane surface is a 2-dimensional surface, and that can extend infinitely. It can extend in all directions infinitely. It has no limit, no boundaries. For example, I have given here as a paper of the book. Although the paper of the book or the notebook is limited, you can say it has a boundary. But consider such a paper which has no boundary. We can extend that paper infinitely in all the directions. So such type of a surface would be a plane surface. Even the walls of the room is confined or it has a boundary. But what if we consider it is elongated or it is stretched infinitely? So that will become a plane surface. Now moving on. What is a curved surface? There is also another type of surface that is called curved surface. Now a curved surface can be defined as a rounded 3-dimensional surface. Now the difference you can see, in the plane surface it was 2-dimensional, but the curved surface has now become 3-dimensional. 3-dimensional means it also has a height along with it. So not only the length of the breadth, it also has a height. And it is also not flat, it is a bit rounded. For example, you can see the surface of a cylindrical object. We already know what is a cylindrical object. Consider a pipe, cylindrical pipe. So this cylindrical object will have a curved surface. So I hope you are clear with this. Now moving on. Next is, what is a simple curve? Now we have come across the surfaces. Now we will discuss what is a curve. There are 2 different types of curve. So first type is the simple curve. Now a simple curve can be defined as a curve that does not cross itself. We know what is a curve, right? So a type of a curve which does not cross itself. It will be clear from the diagram. But before that, let us again see what is a closed curve. A closed curve can be defined as a curve with no endpoints and which completely encloses an area. It is such type of a curve which is totally closed. It has no endpoints, or you cannot say it is not open. It is totally closed. So we'll see one here. There is a table which is given in your textbook. Now you can see here there are some figures, and which will match with which. So let us begin. In the first figure you can see this is a simple curve. that is not closed. Why it is a simple curve? Because it does not cross itself. It has two endpoints. Did it cross each other? No. This part and this part, did it cross each other? No. So it is a simple curve, but it is not closed. It is open. You can see. Now the next one, it is not a simple curve. This is not a simple curve because it has crossed itself. This side and this side, it has crossed itself, overlapping on one another. So it is not definitely it is not a simple curve. Now next one, it looks like a circle, but it is a simple closed curve. It is a simple curve, but that is closed. You can see here, it is totally closed. It is enclosing an area, or you can also say it is a closed curve. It is enclosing an area. This is the area that is enclosed within. So this is a closed curve. Now what about this? It is a closed curve, but it is not a simple curve. It is closed. It is enclosing this area and this area, but it is not a simple one. Why? Because you can see it is overlapped here and again it gets closed here. So these are some of the basic concepts. It might be confusing in the beginning, but if you think it a little bit minutely, the difference will be very much clear. And for this you have to practice the different shapes or different curves. When we deal with different curves, only then the concept of this curve becomes clear to us. Now next, moving on, what is a polygon? The next topic is polygon. So let us see the definition first. A simple closed curve. From the curve definition it comes, a simple closed curve made up of only line segments is called a polygon. Now a polygon, how many line segments should be there? There should be 3 or more. Only then we can say it is a polygon. Since it is a closed curve, if it is less than 3, then it will be open. It will not be a closed one. So it should have at least 3 line segments, made up of 3 line segments or more. And it should be a simple closed curve. Only then we can say it is a polygon. Let us see some figures. So you can see here, it is made up of line segments. These are also made up of line segments, but the difference you can see, these are polygons because you can see 1, 2, 3, 4 line segments, and these are all totally closed. These are also closed. These are also closed. So these are polygons by definition. But these are not closed. You can see this portion is closed. You might say this is a polygon, but no, this portion, this is not closed. This is open. If it would have been closed, then it might have been a polygon. Here also similarly, this area and this area is enclosed, but this area is open. Here also, it is not closed. So this cannot be considered as a polygon. Clear? Now, moving on. Classification of polygons. There are different types of polygons. So what are the different types? These are the different types. Triangle is a polygon having 3 sides. Then quadrilateral, then pentagon, then hexagon, heptagon, octagon, nonagon, and decagon. And there are infinitely n-gons, you can say. So depending on the number of line segments or the sides, you can say, or the vertices also, depending on that you can classify the polygon. So at least it should have 3. That is, the least one is the triangle, which is the smallest, you can say, polygon, you can say, and goes infinitely up to n number of polygons. So this is clear. Now next, what are diagonals? By definition, a diagonal is a line segment connecting 2 non-consecutive vertices of a polygon. Now the definition will be clear if I show you the diagram. Here you can see it is a line segment. You can see this is a line segment. This is the diagonal, we all know. Connecting 2 non-consecutive vertices. These are the vertices. S, R, Q, P. These are the vertices. 2 non-consecutive. You can see here, these and these vertices are consecutive. Consecutive means coming one after the other. So if we'll connect this and this will not be a diagonal. So this and this point, S and Q, these are non-consecutive. After S, directly it doesn't come Q. After S, it comes R. So this Q is non-consecutive. So when we connect such 2 non-consecutive vertices, then we can say that line segment connecting those two non-consecutive vertices is a diagonal. So clear? Now next topic, convex and concave polygons. So let us see the definition. Convex polygon means a polygon with all its interior angles less than 180 degree. This means that all the vertices of the polygon will point outwards, that is called bulging, away from the interior of the shape. Then the reverse of that is the concave polygon. Here, one or more interior angles will be greater than 180 degree. It looks sort of a vertex that has been pushed in towards the inside of the polygon. Now, definition will be clear from the diagram. You can see these are convex polygons. Here you can see the interior angles. These are the interior angles. These angles. You can see these are pushed outwards. All its interior angles are less than 180 degree. This angle, if we consider, it will be less than 180. All the interior angles will be less than 180. And all have been pushed outwards from the interior of the shape. This is the interior of the shape, this is the exterior. And all the angles are pushed outwards. You can see pointed outwards. So whenever such a condition arises in a polygon, we can say it is a convex polygon. And here the case is different. In concave polygon, one or more interior angles is greater than 180 degree. If we consider this angle, then it is greater than 180 degree. It is a reflex angle. We all know what is a reflex angle, an angle which is greater than 180 and less than 360. So when one of the interior angle is greater than 180 degree, then the condition comes is the concave polygon. And in this case, what happens is that the interior angle which is more than 180 degree, it has been pushed inwards. It looks like it has been pushed inwards, the polygon. It is inside, it is going inside, pushed inwards. Other angles are okay, but one of the interior angles will be more than or greater than 180 degree. That means one of the interior angles will be a reflex angle. Clear? Now next, regular and irregular polygons. Let us see what is a regular polygon. A regular polygon is defined as a polygon that has been both equiangular and equilateral. Equiangular means all the angles are equal, and equilateral means all the sides are equal. We all know this. And irregular polygon will be a polygon which is not regular, definitely. It can have sides of any length, and also the interior angles, or you can say the angles, can be of any measure. Some examples you can see. Regular polygons, you can see. Here all the angles, this is the pentagon and this is the hexagon. Here all the angles of the polygon are equal. If you measure it, it will be equal. Here also in a hexagon also, all the interior angles will be equal. Also the sides you can see, they are equal. That is both, these are both equiangular and equilateral. But here, what we will say this? You can say this is also a pentagon because these are 1, 2, 3, 4 and 5 sides. But here, the measure of the sides are not equal. Also the measure of the interior angles are not equal. These are 90 degrees. This is not a 90 degree. Here also similar case. It is also a type of a hexagon, but here the lengths are not same. Also the angles wouldn't be same. So unless and until we measure the interior angles, also the sides, we cannot directly say that a pentagon and hexagon is a regular polygon. But we have to measure it. Only then we can come to the conclusion that it is a regular or it is an irregular polygon. Clear? Now moving on. Angle sum property. We have already learned the angle sum property in the case of a triangle. Now there is also another angle sum property in the case of quadrilateral. So what is that? Let us see. The angle sum property of the quadrilateral states that the sum of the measures of all the four interior angles, there are four interior angles of a quadrilateral, and that should be the sum of all those angles should be equal to 360 degree. That is the angle sum property of quadrilateral. That means here these angles 1, 2, 3 and 4, their sum should be equal to 360 degree. It will always be. Only then we can say it is a quadrilateral. Unless and until it satisfies this property, it won't be a quadrilateral. If it is a quadrilateral, it has to satisfy this angle sum property. So that's it for today. I hope you will have understood the topics. You can go through the textbook once again. And that's it then for today. Thank you and have a nice day.